Hello, Times of MGM. My name is A. Mancraw of Class 10H. Today's news headlines are as follows. First of all, some international news. German railways operators start test driving battery-powered trains. Snow causes havoc in Istanbul. Many stranded. Now some national news. India celebrated its 73rd Republic Day yesterday. People witnessed nation's military might and diversity cultures in a grand parade at Rajpath. India's first woman Rafale fighter jet pilot was a part of Indian Air Force tableau. Now some state news. As many as 20 officials of Chhattisgarh was awarded with medals on the occasion of Republic Day 2020. CG's first sewage treatment plant inaugurated at Balikonta. Now let us move on to some sports news. Param Vishish Seva medal for Subedar Neeraj Chopra. Rohit fit ready to lead team in 6-match series. Last but not least, MGM News. MGM School celebrated India's 73rd Republic Day with patriotic fervor. The celebration was available live on MGM e-portal channel. That is all for today's news. Stay tuned for
Okay, good morning, students. Today in the data science session, we will see data analysis, exploratory data analysis, and conclusions. Then after communications, hypothesis, and EDA techniques. They are the two techniques, quantitative and graphical techniques, that are used in EDA. Okay. Let us start from the first, exploratory data analysis. In this exploratory data analysis, I want to explain data analysis. What is data analysis? The data analysis is nothing but the extractions of data or taking out the important information from a set of data or set of values. This is data analysis. Let us consider the phases of EDA, exploratory data analysis. It is having a four phases. First is approach, second is focus, third one is assumption, and the fourth one is EDA techniques. Let us start the first phase of exploratory data analysis, approach. In this first phase of EDA, we will decide or we will select a suitable model that is fit or that is the best fit for our data set for our data values. We have to select a suitable model in this phase. Second phase is focus. In this second phase, we have to concentrate either on structure. Structures may be the semi-structures. Our data may be semi-structures, maybe the unstructured data set, maybe structure may be in the tabular format, maybe data set, maybe the outlier. The outlier data set means the data that belongs to the boundary of the limits. Boundary of the limits means suppose there would be the lower limit and upper limit will be there. Suppose lower limit is 10 and the upper limit is 50. The data that belongs outside of this boundary, that data is known as outliers data. Or we may select the model also. In this focus, we have to concentrate either one. Maybe the structures, maybe the outlier, maybe the models. Or we can say here we have to select the methods which is suitable for our data set. Focus. We have to focus. We have to concentrate here. Assumptions. In assumptions, we have to means some standard rules and regulations because here we are selecting the model. We have to make some standard rules and regulations. If we are assuming the so many assumptions for this model, so here we are neglecting the so much data. If we are neglecting the huge part of data and for considering only the little bit data, our predictions and the we can say the predictions and the conclusions that will not be the accurate. We are not getting the accurate result, or we are not getting the accurate performance. Okay? Because here we are imposing the so many assumptions and the rules and regulations in our data set or data values. That is why here we have to consider the assumptions or the rules and regulations, only the few, so that we can consider uh, the huge data set. Analysis should be based on the our huge data set. And the last phase of EDA is the EDA technique. In this EDA technique, there are the two techniques we are using: the quantitative technique and the graphical technique. In this quantitative technique, the output will be in the form of the numerical. We can say the output will be in the form of numeric. And in graphical technique, the output will be in the form of some graph, chart, map. So these two techniques we will use in the EDA, exploratory data analysis. This is the last phase of EDA. Let us move to the next slide. First, here we will see the EDA techniques. There, we had already studied about the two techniques. We had already seen the two techniques: graphical techniques and numerical. So first, we will see the graphical techniques. In this graphical technique, we will use mostly there are the so many methods we are using in the graphical here. The first we want to see the histograms, and the later we will see the scattered plots here. In the histograms, we can say the histogram plotting. In the histogram plotting, we will study about the distributions of data set, distributions of data in histogram. The data may be distributed at the center of the graph or center of the map, or maybe the data may be shifted to the left side of the graph, or data may be shifted toward the right side of the graph. It might be possible. It might be possible. If the data means here in the with the help of the histogram technique or histogram plotting, the spreading of the data we will consider how the data is spreading in the graph. If data is centrally plotted, complete data is located at the center of the graph, or maybe sometimes the data may be located at the right hand side of the graph, or maybe the left hand side of the graph. If the data is located at the left hand side of the graph, the right side of the graph is vacant. That is nothing but the skewness of data, or the data may be plotted at the right hand side of the graph, or maybe the here chart, the left part of the graph is completely vacant. This is the skewness of the data. Or sometimes the data may be presented outside of the limits or outside of the boundary. This data may be known as the outlier. The data may be presented outside of the limits. This histogram technique, we can identify the spreading of the data, how the data is distributed in the graph. Next is the scattered plot. This is another technique in the graphical format. We are using the scattered plot. This is in the graphical technique. This is also representing the data in the graphical way. This is representing data in the graphs, maps, and in the some different formats. Here in the scattered plot, here we have to interrelate the two variables. We have to consider the two variables x. Here we are considering the two variables x and y. In x-axis, we are considering the years, and the y-axis may be taking the productions. Here, with the help of the scattered plot or scattered graph, here we have to find out how these two variables are interrelated, or how these two variables are linearly interrelated or non-linearly interrelated, or maybe y is dependent on x or y is not dependent on x. we have to find out with the help of the scattered plot. Means with the help of the scatter plot, we are interrelated with these two variables. This is the technique in the graphical, means in the graphical phase we will use. There are the so many plottings are there are the so many plots we can use in the graphical technique. Here uh, we are explaining only for the two plots, histograms and scattered plots. The next technique is in EDA we are using is the quantitative technique. This is the second technique, EDA, exploitative data analysis. This is the, we can say in the EDA exploitative data analysis was having the four phases. In the, this is the EDA phase, that was the EDA technique, that was the fourth phase. In this quantitative technique, this is the, we can say, technique that was using in the EDA phase. In this quantitative technique, the data will be presented in the output, or we can output that will be presented in the numerical way. In quantitative technique, we are using the two methods to measure the output, to measure the numerical data. The output that will be represented in the form of the numerical way. The first method, we can say, the measurement of the central tendency. The second method we were using is the measurement of the speeding of data. In this first phase, measurement of the central tendency, we are using the three, we can say, we are using the three methods: mean, median, mode. In mean is the point which indicates how centralized the data points are. Median. Median is nothing but it is giving you the middle value of a data set or of a data values. Mode. With the help of the mode method, it is giving you how the data is representing, how many times the data is coming in this data set. This is giving you the frequency. The second way, or the, we can say, the second method, the measurement of speeding of data. With this, we are representing the output. We are representing our output in our numerical format, in the numerical way. In this quantitative technique, the second method is measurement of speeding of the data. For measurement of speeding of data, we are using the three ways we can measure: variance, standard deviations, and interquartile range. All these six methods we are using to measure the output in the numerical format, to display the output in the numerical way. All these six methods having the some formulas. We are not discussing here formulas. Variance. Variance is approximately the mean of the square of the deviations. Standard deviation. Standard deviations is the square root of variance. Yeah. Standard deviations is the square root of variance. Interquartile range. The interquartile range is the distance between the 75th and the 25th percentile. All these six methods, the three methods we are using for measurement of the central tendency, and the last three methods we are using for the measurement of the spreading of the data. These six methods we are using in quantitative technique to represent our data in the numerical format. Okay, this is the six methods. Here, these six methods, they are having the different formulas for representing the data in the numerical format or numerical way. Actually, next, conclusions or predictions. The conclusions or prediction that is based on our, that is means that this is the last part, conclusions and the predictions that will give on our data set. We will predict on the basis of our data how many data we are analyzing, how the data set we are analyzing. On the basis of that, we are predicting. For predictions or for conclusions, we are using the some statistical and the mathematical functions. And also we require the models. We have to design the model. That model we have to test the model, and we have to train the model. Then after we will deploy the model. For testing, training and deployment, we use some methods, technique and some formulas also. The conclusion prediction, this is the last phase of our data analysis. By this we are predicting, yes, our model is giving, our model is 100% accurate, or 100% performance of our model is giving with 100% performance, we can say. Really, let us know what is the meaning of hypothesis. The hypothesis, it is nothing but just, we can say, it is the assumptions. Whatever we are assuming for creating our model, for designing our model, that is based on our data set. Just only assumption. Let us assume, suppose you are solving a mathematical problem. You are considering let x be a variable, let x and y we are considering as a variable. We are assuming. So likewise, whenever you design the model, so we are considering, we are assumptions, we have to make some assumptions. So this is called the hypothesis. This is called the hypothesis. This hypothesis based on the some variables. Whatever we are assuming, this based on the variables. We are how many variables we are considering? Maybe one variables, maybe two variables, maybe three variables. The variables are dependent or variables are independent. If the variables are dependent, so which value we are changing, which variables we are changing, and how many variables are dependent on these variables. We have to consider each and everything for making the hypothesis, for building the hypothesis. Then after we can say predict or we can conclude, or mainly whenever we are doing the research work and the engineering domain, we are mainly using the hypothesis. Then after we can conclude or we can predict on the basis of the hypothesis, on the basis of the research where we can predict, yes, our model that is giving you the 100% or 90% accurate. Accuracy is 90%. That I had already explained. Okay, this research work or this hypothesis mainly using for the engineering domain or the research purpose. Next, hypothesis model, building a model. For on the basis of the hypothesis, we are designing a model. For it is considering the three phases. First is building a model, then second one is the model evaluation, and the next is the model deployment. On the basis of the hypothesis, we have to design the model. Whenever we are designing a model, it will, here we have to consider the input variables, means how many variables we have to consider, on what basis we have to forecast. Okay? Here we have to consider the variables, input variables. Just like I had told you, okay, suppose we are considering the two variables and the three variables. So how many variables that are dependent? How many variables that are independent? Suppose we are changing the one variable, how the second variable is changing, yes or no? Just like the simple thing I want to explain you. Suppose during the rainy seasons, suppose the refrigerators and the production, not the production, the selling of the refrigerators and the selling of your fridges, that in the means the west side, sorry, north side, in the north region during the rainy seasons, the sale will be declining. That will also depend on the employment of employment of the workers. If the workers they have got employed, so they will purchase the product, the sale will be high. Likewise, whenever we are making a model, so we have to consider the variables. Here we have to consider for building a model how many variables are dependent and how many variables are independent. Then after model evaluations, whatever model we have to build, we have to evaluate on the basis of the training the data set and the testing the data set. We have to train the models. Then after the model would be tested. Later on I will explain. Then after we can compute the accuracy and the performance of the model. Then after we can consider the accuracy and the performance of the model. Then after this is the last phase of the model is the model deployment. In this model deployment, we have to use the model for the predictions. Suppose let us assume we have expected that our model will give you the 70% accuracy. But whenever we have deployed the model, at the time the model is giving you the 80% or maybe the 60% data, accurate data. Then we have to check here in the model deployment if whatever we are getting that is our according to our expectations, yes or no. Then after we can predict our model is the our model is better than the existing model, yes or no. On the basis of that we can predict. Next is hypothesis testing. It is a very important part of the testing. After making the hypothesis we have to test. How can we test? There are the two methods we will use later on. I will explain. Here first I want to explain the populations. Populations we will consider if we are considering the total values, then we can say this is the population. So let us assume in a class the 50 students are there. We will say the population is 50. In a school, if suppose 9,000 students are there, we will say the populations of the school is 9,000. Sample. Sample it is a part of the population. If we are considering a few students, then we can say this is sample. Out of the 50 students, class strength is 50, means population is 50. If we are considering only the 2 students, then we say the sample is 2. If we are taking only the 10 students, then we say the sample is 10. Okay. Here we are considering the two samples, sample S1 and S2. On the basis of two samples, we are calculating the mean value mu1 and mu2. These two main mean values are very important, playing the important role for testing the hypothesis. For testing the hypothesis, we are testing the two type of the hypothesis, alternate hypothesis and the null hypothesis. First is what is the meaning of the alternative hypothesis? Let us assume we have already built a model and built a model we can say this is our proposed model. Here in case of the hypothesis testing, our proposed model, the output of our proposed model is better than the output of our existing model. Then we can say this is the alternative hypothesis. In any organizations that is working on our existing model, the some model that is running in our organizations, we want to change in the existing model, we have designed the new model, or we can say this is the proposed model we have designed, and we have tested the proposed model, and we are getting the some output from the proposed model. If our output that we are getting from our proposed model that is far better than the existing model, then we can say this is the alternative hypothesis testing. The second is testing is the null hypothesis. In the null hypothesis, whatever the output we are getting from the proposed model, the same output, this is the same as we are getting from the existing model that is running in our organizations or running in the some company. In the null hypothesis, that is it's meaning coming from the null, if there is no difference, there is no difference between these two model, existing model and the proposed model, then we can say this is the null model. If both are same, there is no use to change the our existing model. If something is better than the existing model, then we can change, then we can adopt the new things. Otherwise, if there is no change in the existing model, then why should we adopt the new proposed model? So they are the two testing we will adopt for the hypothesis testing, alternative hypothesis and the null hypothesis. The hypothesis testing process, whenever we are testing the hypothesis on the hypothesis will be tested on our data set. The 60 to 80% data set are used for the training the model or training purpose. We are using the 60 to 80% data set we are using for the training purpose. Just like a small kid, so I'm giving you an example with the small kid. A small whenever the kids are small, so we are training them. Here, this is our cousin brother, this is our cousin sister, this is the flower, this is the pot. Like this we are training, we are giving training them. Whenever they are going somewhere, so they will identify, yeah, this is the pot, this is flower, and this is the school, or this is the building we are training. Then after 20 to 40% of the data set that is using for the testing purpose, they are going somewhere, they are testing, yes, we find somewhere this is a flower, yes, this is a red flower, they will give the output. Likewise, whenever we are testing the model, the 40, 60 to 80% we are using the data set for test training purpose, and the 20 to 40% we are using for the testing purpose. The communications. It is nothing but it is the important part of our data analysis by which we are communicating to the client or customer. The communications is the different type of the way we can communicate is in the form of the visual graph, we can communicate in the chart, we can communicate in the form of the maps, we are communicating to the customer or clients is in the form of the report or maybe in the presentable presentations. It is a part of the data analysis by which we are sending our result, sending our, we can say, output to the customer or clients. This is the last phase of our data analysis communications to the stakeholder or clients or customer is in the form of visual graph, maybe charts, maybe reports, maybe presentations, maybe the numerical data. Yeah, this is the data visualizations. Data visualizations is the communication, is the effective communications by seeing the data. You are visualizing, you are grasping the so many things. It is a part of the communication. Data visualization, it is the effective part of communication by seeing. Here, the simplifying, you are simplifying this quantitative informations. You are understanding the relationship of our variables, how the variables are interrelated in the graph or in charts. You can easily identify the patterns also, which one is rising, which one is downfalling, the points. Okay, we can also establish the trends also with the help of the data visualizations. We can identify each and everything by seeing the graphs and maps. The plotting. The plotting, it is a we can say plotting is another way of data visualizing in which we are plotting the different types of the variables. Here we are plotting in x and y. In x-axis we are considering the one variable. In y-axis we are considering the another variables. With the help of the plotting, we want to interrelate it between these two variables, or sometimes the y is dependent on x, or sometimes x is dependent on y, or sometimes both are independent. With the help of the plotting we can interrelate it with each other, or we can find out the relationship between two variables. The data types for plotting. For plotting purpose, how many types of data we can consider? The discrete data types, discrete data type, continuous data type, ordinal data type, and the clusters of group data types. And discrete data type, if we are counting the numerical value, we can say the discrete data type. If we can count the number of students in a class, we can say this is the discrete data type, or the countable. If we are counting anything, we can say this is the discrete value, discrete data type. A number of students in a class or the number of employees in an organizations we are counting, this is called the discrete data type. The continuous data type, the continuous data type is the data type that is giving within the range. The data that is plotting within the range, we can say this is the continuous data. If we are giving the height within the 5 to 9 feet, if we want to measure the height within the 5 feet to 8 feet or 9 feet, we say this is called the continuous data. We say this is the continuous data. Cluster group. If we are grouping the same type of the values, the same type of the data, then we can say this is a cluster. Suppose we are clustering the wheelers, four wheelers, we are clustering, we are grouping the four wheelers, we say this is a cluster. If we are grouping the two wheelers, we say this is a cluster. Here we are grouping on the medium size students and the short size student. This is we are clustering. This is the cluster type data. The next data is the ordinal data type. Here we are grouping the data on the basis of their some values. Here after grouping, this is a group is marked as a some rank will be given there. Whenever suppose you are whenever you are going to purchase the some items or some product from the shopkeeper, after purchasing the product from the shop, then the shopkeeper will say yes, please fill this form. After filling it will ask you is how much would you satisfy from our service, or maybe there's some suppose you want to repair the product, you are going to the shop, the product should be repaired by the shopkeeper, then after it will ask you, okay, how would you satisfy my service, then it is asking you the sum in form, it is asking you the range from 0 to 5, this is satisfied, 6 to 8, it is strongly satisfied, or then after you can say this is the well satisfied or disagree maybe. Likewise, we have set a group of the value that is having a name. So this is called the ordinal data. Here the range of the value that is marked as some name. Here the next data type is the timeline data type. Here we are measuring the data is in the form of the time, maybe in the minutes, hours, seconds, month, date. This is called the time series data we can say. Here the for the data visualizations we are using the different types of the plots. Here we have discussed in this session we have discussed only the two plots, histogram plots and the scatter plot. There are the so many types of the plots are available. Histograms is one of the plots, second one is the line chart, third one is the regressions plot, and the fourth one is the heat map, then cluster map, then the scatter plot. There are the so many plots are using in the in the different type of the data visualization. These are nothing but we can say these are the data visualizations technique. Okay students, thank you.